So next we are looking at representing our magnetic field. With the help of what? Similar to our electrical field lines, we have magnetic field lines. So herein, of course, it's also an imaginary set of lines. So basically, if you sprinkle iron filing around a magnet, you will see that the filling arranges themselves in a particular pattern. This pattern represents magnetic field line. So let me show it to you guys. I think okay, it's just a second. So basically, it would be something like this. Oh, sorry, by the way, that was a magnet. And now I'm being a board and stuff. That was supposed to be some experiment for 10 graders, 9 graders. So that's why I'm keeping the word. Anyways, point is you can see that, right? And you guys know this as well. But yeah, I just wanted to show. That is the effect of magnetic field lines. Or magnetic field actually, not lines. So representing this, pointy stuff is our magnetic field line. So as a definition, is our imaginary lines used to visualize the direction and strength of a magnetic field. So when it comes to direction, how do we go about finding the direction? The direction of a magnetic field line at any point indicates the direction of a magnetic force that would be experienced by a north magnetic pole placed at that point. So for me, it's easier to tell than to read. If you take a magnetic field line, like over here, if I keep a magnet over here, draw a tangent, and that will be the direction of your magnetic north. Compass, basically. Let me take one more. So say, let me take this point, draw a tangent. So say this is your magnetic field line direction. If I keep a compass over here, yes, this would be the scenario. So this will be your north and that will be your south. And if I do the same over here, draw a tangent, keep the magnet, and you will see it will be in the same direction. Okay, so let me show that as well. So this is what you guys do in your 8th, 9th, and 10th grade and all of that to draw how to draw a magnetic field line. This is what we do, right? We take a magnet, tape it up, take a small compass, and look at where the south is, something like this. So we keep doing this. Next, we arrange the compass so that the north is pointing to that point. So if you keep following this, if you keep doing that and join that line, that will be your so that is south end because your north is get pulled towards that, I guess. Sorry, this is north end. Okay, you guys can't see this. So what I mean is that the top end of the magnet is your north end, south end of the magnet is your south end. Or sorry, my bad. It's kind of obvious. Obviously, it will be that. So the bottom end is your, in this case, your south end, and the top part is your north end. And that's how the arrows are indicated. That's why I was pretty adamant to mention that. You know, so the magnetic field line starts from the north end, ends at the south end. Within the magnet, it starts from the south end, ends at the north end. This fact is something that we have to be clear with. Small things we need to be clear with. So when it comes to strength, closer the magnetic field lines, stronger the strength. So basically, if I see this and if I see this, so which has more field lines? Case A. So this is stronger than B. Okay. Then poles, magnetic field lines emerges from north pole and merges at the south pole. Inside the magnet, they run from south pole to north pole. Then non-intersecting magnetic field line will never intersect. Reason being, it's to do with force. We can't have force in two different directions. Always the net force that is taken into account. And so no two field lines will be crossing each other. It's the same thing as what we learned before. Closed loop. This is the extra bit. Magnetic field lines form continuous closed loop without beginning or end. This is because magnetic monopole does not exist. So there's no per se just north pole. If you see north pole at certain distance, you will see south pole as well. And finally, vector nature. Magnetic field lines have both direction and magnitude, making them vector quantity. So all this is your 8th and 9th grade syllabus. But yeah, here too you guys have to revise.